A very good evening to all of you present here. On behalf of EDUSOFT, I welcome you all in this small session on data literacy and how do we deal with data with using the Tableau tool. We are very clear that everybody deals with some sort of data, no matter how big or small or how complex or simple it is. On regular basis, we do that. Now, if we talk about how does the data look like, some of the data is very symmetrical, like examination details, marks details are very symmetrical. It's a 2D arrangement of the data, which is very simple to understand. Mostly the data is tabular, which we deal with. There is some other kind of data which is called complex data, for example, images, maps, and all those kind of things are there. So I'm not going into those complex data type details. We'll be dealing mostly with numbers because we are going to apply basic statistics which works on numbers. Data literacy, when we talk about, we just discussed about data, we deal with the data. There is no point of defining the data, we all know. But when we talk about data literacy today, so how do we say that a person is data literate, or how do we call ourselves data literates? Because teachers are looked upon to be well versed with dealing with data and knowledgeable people. They read a lot, they teach, they learn. So automatically we assume that if a teacher is there, that teacher would be data literate, and one has to be. Today, no matter which profession you are in, or you might be in a profession or not, doesn't matter. Data literacy is a must. Up to some extent, we deal with the data, and we should be able to do that. Now, when we talk specifically about data literacy, what are the abilities of a person which makes him or her eligible to be data literate? So the first thing that we look into data literacy is, how do we gather the data? Are we able to gather the data? There are different means of gathering the data. What are the sources of data? If we are able to figure that out, that if I'm going to need some data, where would I get it from? Number one, the source of data. What means I will apply, what tools I will apply to gather that data. That is one aspect. And once the data is with me, how I'm going to organize it. So that comes into data gathering, or procuring the data, or gathering the data, or you can say collecting the data. So there are different ways. For example, after the session, if I share a feedback form with you, I am gathering the data from you regarding your response about the session. That is one small example. And there are several hundred ways depending on the sources. It could be a simple text file, or it could be a complex website. Data can be extracted from any of these sources, databases. So the ability to gather the data, that is one eligibility criteria. The second eligibility criteria to be data literate is to understand that data. So I have gathered the data is in front of me. Am I able to understand it? Now, understanding the data and interpreting the data are two different things. Understanding the data means you can figure out what type of data it is. Is the data properly sorted or organized? What are the columns? How many rows are there? If it is tabular data, or what kind of data? Is it complex or simple? So that is understanding of data. I'm able to, I know my data. But when we talk about interpreting the data, that is deriving the conclusion, which is the actual purpose of collecting the data, that interpreting the data in different ways. So if you show one data set to different people, all will be coming out with different interpretations. But understanding of the data of those people should be same. So if 5 people are looking at a data set, their understanding of the data would be similar, but their interpretation of the data would be different. Because people are looking and trying to extract information out of the data according to their perspective, according to their requirement. So this is the basic thin line of difference between understanding and interpreting the data. Now, I have gathered the data. I have organized the data. I have understood the data. I have interpreted the data. the next step is to communicate in the form of data. So if I have some information, am I able to summarize it into short and in a meaningful way? And I should be able to convey it to others in the form of data itself. So if I have the marks of 100 students and somebody is asking, create a summary of this data. So am I able to summarize that data into a small sheet? That is called communicating in the form of data. So generally, when we organize the data, if we are giving it to somebody, if we are showing it to people, presenting it in some form, so that is communication. So I summarize again: collecting the data, understanding, interpreting, and communicating. So if I am able to do all this in terms of data, I am a data literate person. So this is the basic foundation of data literacy, which I have laid down here for your understanding. Now, let's see some simple example of data which I have, and let us see how do we understand that data. So as you see here, there is a small data set over here, and it's quite familiar. The marks of the students in 2 grades are over here, and you can easily figure it out. There is nothing complex in understanding this data. Some 12 students are there, and their data is visible here. If we look at this, another set of data, this data is dealing with it is showing me the price of one vegetable in Delhi, that is price per kg, and price of the same vegetable in other cities, in other regions. So this data is actually showing how the fuel price is affecting the price of the vegetable over here. So that's a completely different kind of data which you saw earlier. If you look at marks data, it is a comparative data. You can see, you can just figure out how students are faring in each grade. You can sort this data on the basis of grade, and you can see what all marks are there. You can take the averages and you can compare the values. And here in prices data, you see there are 2 aspects. The fuel is affecting the price of the vegetable in 2 regions, Delhi and other. Now, when we talk about another data set over here, so this data is a little rich over here because it is showing the workers' age, their income, and how much are they saving in an year or maybe in a month, and what kind of worker he is, what kind of employee or professional he is. So is he a student, a professional, or a freelance worker? So I've taken 3 categories, and in these 3 categories, the age, income, and savings data is captured. So this data has so many aspects. First of all, 3 categories are there, and for each category, there are 3 parameters: age, income, and saving. So this way, this data is a bit richer than compared to marks and the prices. Now, in prices, you see the fuel aspect and vegetable price in Delhi and vegetable price in other region. These 3 parameters are there. If you look at another layout of the same data, let's have a look at this. Now here you see the same data has been arranged in a different way. Here the region has been taken like this, all Delhi records and then all the other region records. So I have just changed the data, just changed the view of the data differently. So did you see these are the various examples of data and how same data can be laid out in a different way. So this I just wanted to show you for your understanding that the data is in front of us. Are we able to understand the data? Interpretation comes when we apply some statistics rules, or apply some formulae, apply some functions, or we apply some tool to take out useful information out of the data. So the purpose of showing you this data is that you should have the fair understanding of how the data is looking like and what kind of data we are going to practice with. Now, when we are looking at the data, there is one very basic calculation that is called averages. When we talk about average, so if the marks of a class are there, suppose there are 50 students whose marks are there in the data set, and we take an average of those marks, well and good. We can see the average, that is the mean value, the middle value. That is fair enough if the marks of the students are not varying too much. For example, all the students are good in studies and they all have secured the marks between 60% and 75%, for example, or 80%. So all the marks are between 60 and 80%. So taking an average is good. Doesn't matter much. But imagine out of those 50 students, 5 students failed the exam. 5 students have got, say, 20 marks. Now the entire average is shaken. The entire performance, if you're assessing your performance as a teacher by average, now it is the performance has gone down because 5 students have spoiled the overall result of entire class. The reverse can also happen. There might be 5 or 6 students who have scored above 90. So the average is looking very good, impressive, but that is only 5 students, not all of them. So the balance of the data has to be seen. That is one purpose of analyzing the data. First of all, we see how the data is spread out, how the data values are laid out in the data. And if they are not spread out properly, that means they either need cleaning or some arrangement, or they should be excluded. For example, if 5 students have not fared well in the exam, they have got 20% or less. So what I can do, I can remove those 5 students from the data set and then I calculate the average, it will look good. So I can figure out that how much they are affecting my good average. And I have to work more with these students to improve my average and overall result. So that is the matter of average. Averages work very well if the values are closer to the center of the data. They are closer to each other. They are spread out evenly. Then average is also even and almost realistic. But if there are values which are preposterous, some of the values are going beyond the limit, then average is shaken. These values which are going beyond the limit, 17% marks or 91% marks, and rest of the class is in the range of 60 to 80, these beyond the limit values are called outliers. Outliers are those values which are far away from the density of the actual data. Most of the data is dense. It is collected around the center of the data set, and some values are quite scattered away. So those are called outliers. And because of outliers, our averages are either they come down too much or either they grow up too much, and which are not realistic. So when the average is not realistic, it is because of outliers. So this is one aspect I have told you. Another aspect is we see how the data is spread across. How many students have got similar marks, or how many students have got distinction, how many students have got 60% or above. So these kind of questions and analysis we do in the exam marks as teachers. We do it almost on regular basis after the exam to see how to improve the results in future. Well, so let us see now how do we present all this data and its interpretation in Tableau. So this is, when you open Tableau, the screen will look like this. When you are opening it for the first time, these windows, these thumbnails would not be there, because as you work upon it, your work will be added as thumbnails as the main screen. So this will be completely clean when you open the Tableau for the first time. And here I can connect with so many type of data. I can connect with a text file, JSON file, MS Access database, Excel also. And I can connect online with the server also. If I have some data server somewhere deployed and all the database is there, I can connect with that also. So here we are keeping the thing simple. This is Tableau free edition of Tableau desktop edition. That is community edition or public edition, which is free to use, open source. and it will allow you to deal with the data, which is mostly locally efficiently. So I go to Microsoft Excel over here. And when I click on this, it will ask me to select the Excel file which I have used to store the data. So I have this income data file over here. I will open this. And as you see here, all the sheets which are there in the Excel file these are the sheets available over here. They are shown. Now, whichever sheet data I want to work upon, I will bring in that sheet over here. I am dragging, dropping marks sheet in the blank area over here, and all the data is displayed here. It is showing me what all the fields are there and uh, what is the data over here. So it is laid out over here just like in Excel. That's the first step. You are able to see your data which is there in Excel inside Tableau like this. This is called data source. You see at the bottom there is data source tab, which is the very first one, which will show you all the data which is there. Now, when I work with this data, I can work with this data in different sheets available in Tableau. Sheet 1 is by default over here. If I click on sheet 1 at the bottom, I can add more sheets, of course, but let's go to sheet 1, which is by default added there. And of course, naturally, it would be blank because this is my work area where I will do operations, various operations on data. So here, if you see student, grade, score, all these fields are available over here. There are other strange names also, don't worry. We will have a look at them later on. But I should be able to see the fields which are there. So grade is there, student name is there, and score is there. And as you can see, grade and score, that was a numeric data. They are separated, and student is discrete data. Discrete means it is unique in itself. That was the name only. So that is there in that is shown separately. But if you think over grade field, now grade is of course numeric, but we are not going to perform any arithmetic on grade. We are not going to take the average of the grade. So this kind of data, which actually looks like numeric, but actually it has to be discrete. It has no arithmetic is required on it. We can change its type. So here what I'm going to do is with grade, of course, score per, I will be performing operations on score. But on grade, there is only 9 and 10, two grades are there. So these are categories actually. So what I will do, I will go to this grade field over here on the left side, this data panel, and I open this small arrow and I say convert to discrete. So I'm converting this value to discrete. Number one. Number two is, again, I'm opening this list and I'm saying convert to dimension. So I have just converted the grade into dimension. Dimension are in Tableau, dimensions are those type of values for which you are going to categorize the data. For example, classes or cities or regions or departments. These all are examples of dimensions, categories. Student is also discrete data. Now, score is only, which is the numeric data on which I will perform the calculations. See here. So let us see. If you look at the sheet, at the top, there is column and rows. These two. So column shelf is there and rows shelf is there. So let us start with our data, marks data. So I'm bringing the score. I'm dragging the score field and I'm bringing it here. I'm putting it in columns. The moment I put it in columns, it has taken automatically the calculation sum. It has taken the calculation sum. If I put it in rows, it will be like this. Whichever way is comfortable to you, you can keep it like this. So I have taken sum of all the scores. So sum of all the scores is the score itself, because there are 12 students and 12 values are there. But with this, you cannot figure out anything. It is only just graphical line of sum of scores is shown over here. even if you click on this, you go to measure, and in measure, if you take average, does not make any difference. Fine. So with this, you cannot figure out still anything. We have to add other aspects also. So let us see what all other aspects we can add over here. I drag the grade and I put the grade in rows. As I put the grade in rows, grade 9 and grade 10, now the data is segregated. This makes a little sense, but not much. I have just split the data into class 9 data and class 10 data. If I change this to, if I interchange them to rows and columns like this, so it is looking like a column chart. Earlier it was a bar chart. Now, nothing is with, I can say, if I bring the data here, it is showing me the total score, sum of score, or if I take it as average. So when I bring the pointer, it is showing me the average of class 9th is 59% and average of class 10th is 84%. That is all. That is what it is showing me. If I had added a student instead of grade, I would have got 12 columns. For example, instead of grade, if I add a student, so you see for each student, I have got one bar over here. From this drop down, I have selected entire view. So entire sheet screen is covered now, which is more clear now, zoomed into like that. Then what I'm doing here is, watch carefully, here it is showing in this panel, it is showing color, size, label, detail, tooltip. So we are more concerned with color and labels, because with color we can distinguish between the categories, and with label we can display values over these bars. So if I say, if I drag this student over here and I bring it over the color, watch carefully what I'm doing. I drag the student over the color tab, and as the color tab is highlighting, you see the color tab is highlighting like this, I'm leaving it. So student is added over here in this panel, and it is being distinguished by various colors. See here. So every student has a different color. So this way you can change the color in Tableau like this. You can always format. You can open this small menu beside the student. You click on format, and here format panel will open up and you can make changes in font, color, etc., etc. I'm not touching this just to save time. So that cosmetic part you can do on your own. And once this is done, you can close this panel. Format student panel has opened. I close this and I come back to the data panel like this. Now, again, what I will do is I drag the score field over here and drop it over the label tab. As I drop it over the label tab, you will see the labels are displayed over here. So we are dealing with average, so I better change it to average. Measure average. So it does not matter, average of one student is the marks itself. So that would have been useful if we are dealing with grades. So I have just shown you how a simple graph is made by dragging, dropping values in columns and rows over here, and how to distinguish them by the help of colors and labels. Now we can drag, drop same fields on colors and label tab like this. So instead of a student, let me click on this and say remove. I click here and say remove. And I take again the grade over here. Instead of a student, I have taken the grade on color basis. And I have this average over here, 59 average, 84 average of grade 9 and 10 respectively. So I have taken this very simple, small example so that, first of all, I should be able to show you how you create a simple graph, placing things and what all these components actually mean. This is a standard view. So this is how you place the values over here. And I also showed you that if there is a numeric value which should be a category, how to convert it into a category. You click over here and you can convert into measure or continuous. So there are certain terms which you have to note down. Dimension means category. The keyword is category. If you are converting a value or if a value is a dimension, then you can use it for categorization. For example, city, grades, region. These are the examples of categories. But if a value is there on which you have to perform calculations, for example, price, salary, marks, score, these are called measures. Measures in Tableau are those values on which you perform arithmetic operation or a statistical operation. So these two basic things you should know. Second aspect of data literacy is that numeric data is normally of two types. One is called discrete data and the other is called continuous data. Discrete data are those values which are unique in themselves. Continuous data are those values which are changing over the time. For example, if I'm talking about discrete data, salary of all of 20 employees, salaries of 20 employees in a month, this is a discrete data. Fine. But if I'm talking about one employee over the year, so the 12 salaries of one employee, if I'm looking at it over the time, either it must be increasing, of course. In ideal terms, salary increases. So this is continuous data. Temperature is a continuous data. Height is a continuous data. So these all are continuous data. Continuous data is very useful in doing predictions for future. If I can look at the historical data, I can develop some relationship between the data. I can predict, okay, next value would be this. So discrete and continuous. If you're dealing with numeric data, these are the two categories, discrete values and continuous values. And all these are over here. If I click on a score, you see it is saying convert to discrete. Convert to discrete means right now it is being dealt with like continuous data. Fine. Similarly, if I go to grade, in grade it is saying convert to continuous. Right now it is a discrete type of data. So in Tableau, when you bring in the data, you have to decide which data is going to be continuous, which data is going to be discrete, number one. Number two, which data I'm going to use to categorize the things, and which data I'm going to use to apply statistics upon, arithmetic operations upon. So I guess you have made the note of it, that any value on which you do calculation, that is your measure. Measure could be discrete or continuous. Any value on which you are not going to perform calculation but categorization, that is your dimension. And you are not going to perform any arithmetic on it. And that is clear, I hope. So this is one very simple introduction to how to create a sheet. Let us see what all we can do here. Let me add another sheet. At the bottom, there is plus sign button over here. I can click on it and another sheet will be added. This is sheet 2, which is blank. That was sheet 1 earlier. So I'm in sheet 2 now. And let us see what we can do. For example, I add the score over here. And at the right hand side, there is a button called Show Me. You see this button, Show Me. If I click on it, it will show me some possible graphs which I can make on the data. So some of the graphs you see, they are not enabled Some of them are enabled. That depends on what kind of data you have added over here. So what I'm going to do is I'm to take this graph. This is called histogram. Now, histogram actually is the use. What is the use of histogram? With the help of histogram, we can see the spread of the data. And how do we do that? When we want to see the spread of the data, one way is to arrange the data into various blocks. For example, if I want to place the marks of the students in 25, right? Like how many students are there in the range of marks 0 to 25? Then from 25 to 50, how many are there? From 50 to 75, how many are there? So I want to do 4 partitions. So for 4 partitions, I can create a histogram. A histogram which contains 4 partitions, and it will put the data in those 4 partitions depending on the marks obtained by the student. So if a student has got any marks less than 25, he will be put into the first block. Any student who has got 80 marks, he would be going into the 4th block, and so on. So here there are so many blocks are created which are done automatically. And when I took this histogram, you see what change has happened over here in column shelf and row shelf. In column shelf, the bins are created. In row shelf, the count of the students in that category. When I'm saying category or block, that is called a bin technically. The group of marks which I'm creating. So I want only 4 groups. In the data tab, this score bin is added right now. It was not there earlier. When I selected histogram, this score bin over there is created. So I click on this arrow over here and I select edit. When I click on edit, in this pop-up, here it is showing size of bins. So I want the size of 25. I want to create bins of 25 each. So I'm putting here 25 and I'm clicking on OK. And you will see the 4 bins are created here. I click on show me and this is gone. As you see here, with histogram, I have created 4 bins of 25 marks each. You can see 0 to 25, or you can say 0 to 24.99, 25 to 50, 50 to 75, 75 to 100. And if I want to see the values over here, remember how did we do that? Grade is there, measure. Actually score had to be taken. And the count had to be taken over here. By automatically it takes sum. I touch it to the label and the labels are shown here. Now this is correct. So I should have taken this count score. Another way to do this is, if it is not there, no values are visible over here, the count score is over here, and I want to show that count on the graph also. When I bring the pointer, it is visible, but not like this. What I can do is I can press control key. Control key will create the copy of that. And with control key down, I can click on this count of score and drag it down. A copy is created. So now it is saying between 0 to 25, there is one student who has got marks between 0 to 25. If I go to this data, marks data, 0 to 25, 17. Yes, one student is 0 to 25. Can you see? So it is showing me here. If I say, that means marks between 75 and 100, there are 8 students who have got marks which are more than 75. So this way, I can create histogram and I can figure out how my class is faring. So I can clearly see that there are 2 students on whom I have to pay more attention. They would be left behind. There are 2 students who can improve better, who can do well with little guidance. So I will focus on them in a different way. And 8 students can take care of themselves. They are doing well and good. So this kind of analysis can be done with the histogram. And I can also see the distribution of data. So if my class were doing entirely well, there would be only one bin populated. Like you see, out of 12, 8 students are in best category. So this way, I can analyze the data. Again, I said, if you show it to the different people, they will be interpreting the data in different ways. That's why Tableau has got different kind of graphs and visualizations. So this is one small example where I have created a histogram. Now, let us see. This histogram is actually talking about overall data. Let us add another dimension to it, the grade, class-wise, grade-wise. I drag the grade from here and I drop it over the color tab. When I drop it on the color tab, my histogram has changed. And now it is telling me a different story. Can you figure what story it is trying to tell me? The filter is created over here. You see, if I click on 10, only the details of class 10 students are shown. This is 9. And if I click outside, this is all of the students. So here what is happening? Out of those 6 very good students, 8 students, 6 are from class 10 and the 2 are from class 9. So it is again going more into the details of the data. So had there been more parameters, here we have only one parameter, the grade. But if we had more parameters, for example, subjects or test, we would have gone into more details into the same kind of data. So this is how you work in Tableau and you perform calculations, you create visualizations to understand your data. Now, let us add another sheet over here. Or I take a new sheet. I click on File. I can save this also. I can save it as a simple file. I can give it a name and I can save it as TWB file. I'm not saving this. I'm creating just another new sheet, new file. One file of Tableau may have more than one sheet. So another file is coming up. This is another file. That means blank data source is there. So I can get the data from here. This is the data source. You see here, sheet 1 is blank. When I click on data source, it is asking me to select the data source. I go to Microsoft Excel and I take the same sheet over here. I have put all my data into the same sheet, same workbook. The only difference is that I'll take a different worksheet. So if I take prices over here, so now I have got the data which is different depending on the fuels. The potato price in Delhi and potato price in other regions is shown over here. So I can analyze this in another sheet over here. This is sheet 1. And here all the data is numeric. All the 3 values are numeric. So I add fuel. And potato Delhi, potato other region I have added over here, or let's say just potato Delhi right now. So the moment I am dealing with 2 types of numeric data, it has created a scatter chart, but this scatter chart is showing the cumulative value, the sum of both the categories like this, fuel and potato Delhi. Only one data point is created. But how do I get the individual values? So whenever you are bringing in 2 numeric values in columns and rows, now this data is actually one type of data is affecting the other type of data. The price of the fuel is affecting the price of the vegetable. So here, to get the individual values in the graph, what I will do is I will open this analysis menu in the top. At the top, there is a menu bar. Open the analysis menu and you remove the aggregate measures. Aggregate means sum, count, average, etc. So I remove the aggregate measures. This tick mark is there. I uncheck it. and individual values have come in. Now I can figure easily. And as you see, once the individual values are added over here, here is the data tab, data panel. With data panel, there is analytics panel. I click on analytics. Analytics panel allows me to analyze the data in very different ways. So one simple way is trend line. I can take this trend line and I can drag this trend line over the graph linear. I want to see the linear regression or linear relationship between the fuel price and potato price in Delhi. And it's a perfect regression that shows that as the fuel is increasing, fuel price is increasing, the potato has become expensive in Delhi. What about the other region? I go back to data and I can add other dimensions also, like potato price in other region. I can add it to rows and I will have something like this. Did you see? The two scatter charts are created, Delhi and other. So regression line actually is telling me how closely the data, one data is affecting the other data. If I'm getting this straight line and all the data values are falling closer to the straight line, that means the correlation is very strong and positive. It could be negative also, but here fuel price is rising and the potato price in Delhi is rising. Hence, it is a positive correlation and very close, very intense correlation is here. But if you look at the other regions, in other regions, there are certain values which are falling far from the line also. That means in certain cases, the much effect was not there of the fuel price over the potato price in other regions. But in Delhi, it is a direct effect. So this way, various conclusion can be drawn. So you can, with the scatter chart, you can actually check how one variable is affecting the other variable. So here, one variable is fuel and the other Y, the two Y variables are potato price in Delhi and the potato price in other region. So I have two scatter charts and I can derive my conclusions from this. So this is one very simple example to show you the how do we see correlation between the data values. So this is the prices. This was the data set which I used. And I showed you another arrangement of the same data. The fuel, potato, and region where the data is arranged like this. See, the fuel price is repeating 55, 55, but regions are different, values are different. So if I try to create a chart over this, how does the chart look like? Let us see. So I take another file. I get the data from the same file. And that sheet was actually price is one. I drag drop over here. The data is like this. Region is the field name. I go to sheet 1 and I take the fuel in columns. And potato in rows like this. I go to analysis and I say aggregate measures. I uncheck this. Now both the values are over here. The two regions were there, remember? I can even select the region from here and drag it over the color. If I drag it over the color, the two regions are colored. Blue ones are Delhi and red ones are other region. Let me drag the region again onto the label also. If I drag the region on label, I get the names also clearly. So color and labels both are there. I can easily figure which value is what. Now I go to analytics and I add the trend line. So the scatter chart which you saw earlier is those two are combined into one. That is because the same data had been laid out in a different way. So here is the region wise. You can see how the Delhi potato price and how the other region potato price are affected by the fuel. So this is I wanted to show you that data can be presented in Tableau in different ways. Let us see another example. I'm again taking the same kind of data. The price are there and I go to sheet 1 and I try to create a scatter chart. I take fuel over here as usual, let's say Delhi, and I take the individual values. Can you see this data is not correlated? What about the other regions? Completely not correlated. Such a scatter is there. So there is no correlation. That's just one example of the same scenario, which is showing that fuel price is completely not affecting the vegetable price. So we want to see the correlation sometimes. Sometimes there is a question, what has caused this? Correlation means what is the effect of one value over the other? Number one. Number two, what is the reason of this event? Like fall in the employment, fall in employment during COVID region. So during COVID time, the fall in the employment was too much. That was correlated. That was, you can say, cause and effect kind of thing. So one thing was the cause of another thing, another event. So either you have to see what is the cause of any event, or you have to see how one data is affecting the value of another data. That is called correlation. And here we can see the correlation is not there at all. We will discard this data. So whenever we do not find any correlation, we discard that data useless. It is of no use because we cannot relate and we cannot see any trend. We cannot figure out anything from that. So I have just shown you one example where you find that data is not useful. So friends, we have gone little more in detail into Tableau. My purpose was to show you, first of all, how we start with Tableau, how we bring in the details into Tableau, and how do we arrange the details on the sheet. There are 100 ways of working with data in Tableau. I have shown you two small examples only. The purpose is that whenever you are going to use Tableau in the classroom, you should be more comfortable and you should be able to show your simple examples to the students regarding data visualization. So I underline one important thing is the big question is, why are we analyzing the data? I showed you, we saw the prices, we saw the marks in various visualization, in various patterns. What was the purpose? Why did you do that? That is the big question. The purpose is to answer certain queries out of the data. For example, I want to improve my class. Suppose I have taken the exam of HTML. A test of HTML I have taken for the students, and I have covered 3 topics: attributes, images, and tables. There were questions about attributes, images, and tables, and I have collected the marks. So attributes, images, tables, these are categories, these are dimensions, and marks in them are the measures. So I can create a chart and I can simply compare and find out which student is weaker or which student is stronger in which particular topic. I will find that certain students are good in making table in HTML, but the same student has not done well in attribute. So that student will be able to create a table, but that table will not look very beautiful because he will be weaker in attributes. So I have to teach him. That with table, there are so many attributes you have to learn. So this is, I'm giving an example of how you take the conclusion out of the data to improve on the students. So whenever teacher is analyzing the data, there are two big questions only in his mind, in her mind. One, the performance of the students, and of course, his or her own performance. Because the student's performance is your performance. So that is the basic concern with marks. But if some person, suppose I have a shop, I have a general shop where I sell 200 items. Now 200 items is a big data. Fine. So for that, I have to sit with Tableau and I have to see in a given month, what all items are actually sold very much. That is called faster movement, moving items. Which items are non-moving? Non-moving means for whom the demand is very less. And then I can categorize confectionery, cosmetics, daily use, stationery. So these are called various dimensions, various categories. So I was talking about a shop where a lot of data is there. So I can categorize the data into various types of items. If stationery was non-moving, I'm not going to spend much in stationery. Whatever items are there, I'll keep them to sell until they are sold. Stock out, then I'll buy more. Some items are very fast moving. I will try to maintain their stock so that customer does not go empty-handed. So this is one example of analysis in a shop. So depending on this kind of data, I can take out various conclusions from the data. So just one example given to you. So let's go back to Tableau again and see what all Tableau teaches us. Let us take the marks example again because that's a small data set and easier to understand. I go to sheet 1. Grade co I am converting to discrete and converting to dimension. Grade has gone up. Score is there. The data is properly set over here. Then I take the score and put it into rows like this. And I take the score over here. The sum of score is shown over here. I take it as an average. I go to measure and I say average. So average scores are there. And then I take grade and put it in columns. So I have two grades over here. I can again drag drop grade over the color. The colors are distinguishing now. Now here at the top, if you want a quick summary of your data, you have this button. This called show hide cards. All the panels which you see, they are called cards actually. So I open this small list, show hide cards, and I click on summary. If I click on summary, it will show me the quick analysis of my data. See here, average of 9, 10 combined, minimum value, maximum value, what is the median? Median is the middle value. The value which are, if you sort the data, the centermost values is called median. So if you have odd number of values, suppose 7 values are there, then the fourth value would be the median. If it is an even number, then the centermost two values, that average is taken and that is the median. I have a filter also over here. I can click on particular section and see that some summary changes accordingly. See? So this way, I can see the quick summary. If in this card, if I open this tiny arrow, I can have more calculations over here, standard deviation, first quartile, third quartile, etc. These are some advanced statistics topics. So if you require them, you can simply click them and that would be added over here. I can resize it. So this is how summary of the data can be quickly seen from here, or you can hide it also. Well, now I have over here, score is there. I press Control key and I bring the score down here also. Now, if I right click here in this card, if I right click and say new calculation, so it can allow me to perform a new calculation. For example, if I say max, I can use max function, and within a square bracket, I can give the field name score, for example, and I press enter. Just a moment. Max, within max function, I take a square bracket score, close the function, I press enter. Max is here. So this way, I can right click and I can add more calculations for myself. What all was shown over here in summary, I can do manually also. You see now summary is changed. Max score ka summary is shown separately. Similarly, I can right click and I say new calculation, and here suppose I say percentile. In percentile, I say score, and I give a number, suppose 0.25. Percentile score, I am doing all the calculations on score, and I say 0.25. So by definition, what do you understand by percentile? In percentile, we decide one percentage. For example, I have given 0.25. 0.25 means I have taken 25%. And I want to know how many students have scored 25% or less. Percentile means you decide a percentage. For example, you say 90. What is the percentile of, what is the 90th percentile, you can say, or you can say what is the percentile of 90% in this data. What you mean to say is what all have scored 90 or less, not more, 90 or less. All those counts will be the percentile. So I'm just saying ki all those who have got 25% or less, this is the percentile over here. Percentile is 38.75 and here percentile is 81.50. So 25% of students of class 9th have secured 38.75 and 25% of students of class 10 have secured 81% marks. So this way, I've just taken one example percentile. It could be any other calculation. For example, let's say if median is there, of course, and I can say score again, and here is the median. Median I can add over here. So it is showing me the median now. Median is the middle value, as I told you. So all this will tell you about the spread of the data. So whenever a data science analyst, whenever a data analyst is dealing with the data, the first thing he looks for whether the data is clean or not. Clean means the data has to be perfect, the data has to be useful, and unwanted data has to be removed from it. There shouldn't be any null values. The data should be correct and the value should be valid and in a uniform way. For example, somebody might have written the age as 25, somebody might have written the age as 60th or 60 years. So it has to be numeric value. All of them have to be numeric values in a particular format. So values should be uniform, accurate, and valid. That is first thing a data analyst looks at. Once the data is clean, data is formatted properly, the second thing is the data analyst looks at the spread of the data, how the data is spread out across. So for spread of the data, we take averages, we take minimum, maximum, we take median, and we try to figure out how evenly the data has been spread out. If data is too much scattered, it is very difficult to analyze and the predictions will be incorrect. So data has to be very clean, data has to be close enough. All the data values should be in a uniform way and they should be spread in a symmetrical way, or they should be closer enough. The spread of the data. Then third thing a data analyst looks at is whether the correlation between the values is there or not. If you are trying to predict something, suppose we are trying to predict that this customer, this subscriber will watch the next movie or not on Netflix. So we will look into what does the customer, what does that subscriber likes actually, what all kind of previous movies he has seen. Has he seen horror movies? He has seen thriller movies or drama or romance. So we will look at the interest of the person. Then we will look at the frequency, how often he's watching these kind of movies. And with these parameters, we'll try to figure out whether how many percentage chances are there that this person will watch this movie also. So here we are trying to make correlation between the data. And suppose there is a viewer who has a very different kind of choices. Sometimes he watches drama, sometimes he watches horror. There is no pattern in his viewership. For that particular viewer, it is very difficult for Netflix to predict what kind of movie he is going to watch next. So this is called, there is no correlation between the data values. Fine. So I've taken the example of relation and correlation. That is what a data analyst tried to see. When all this is there, the correlation is there, the data is properly spread out, then only conclusions are derived. So deriving conclusion is the very last step. Before that, so many things are done. And in finding the spread of the data and in finding the correlation of the data, we need to visualize the data. So what I'm doing in Tableau, what I'm showing you being done in Tableau is actually data visualization to check whether there is a correlation, whether the data is spread out and how the data is spread out. That all I'm doing over here. So let us quickly see another example of this. I take another sheet, and in this sheet, I take the score and grade. Or let's say I take a student. I take a student in column. For each student, let's do this. And I take a score in rows. I have this column. And for a student, I take the student to the color tab also, touch it into the color tab. So it is very beautiful looking, different values. And here is the filter also. I can focus on one student at a time also. So all this is there. I can have a quick summary over here. Some basic values are over here. I can derive certain conclusion from here. So median is 82. So most of the students have secured around 82 or 80s. The marks are in 80s for most of the students. So what all I can do over here? I can see the labels also. If I bring the score over to the label, I can see the marks over here also, quite visible over here. I can add new calculations in the graph also. I'm not doing right now, but this is how we can do. Right click in the panel over here, and you can go for any new calculation. So this way, this data is over here. Now let us analyze the data. I go to Analytics tab, and in Analytics tab, I click on average line. I drag drop average line over the graph. An average line is added over here. So it is showing me that average is 71.9. So you can see in quick summary 71.9. So visually my average is over here. So visually I can quickly see that very few students are below average. Most of them are doing good. So these are the three students. Student 4, let me open it into full view, entire view. And I can see over here that student 4 and student 10, they need more attention from me. Student 11 can be motivated, he can do well. So this kind of conclusion can be done. So just by taking an average line, I can figure that out. Let us see more spread of the data. I will add median with quartiles. Median with quartiles I'm dragging, dropping over here. So it is showing me what is the median value. Most of the students are in 80s. They have scored the marks in 80s. So median is very, very good for me. If had median been very down, my students wouldn't have done well. So median of 80 something, here median is 82. So this class is doing very well. So if I go to my data sheet over here, I go to marks and I change my marks over here. Suppose instead of 88, I make it 23. Some of them another 14, then 12. So I have manipulated some marks just to show you. I have changed the data, I have saved my sheet, and I go back to Tableau. But Tableau will not show the data refreshed over here. I have to do it by one command. What I will do, I will go to data menu. Now this is important. Suppose you have made changes in the data in the sheet, the source sheet. How will you refresh it? So you go to data menu, you go to marks over here. Marks is that sheet which you have added over here. And here you will say refresh, or you can press F5. Yes. So did you see? Now the scenario is completely different. I have 5 red cases which I have to focus upon. And median has come down. Did you see the median has come down to 70? Average is also fallen down. So this is how you can see, you can do the analytics over here. Let us see if I add reference band. Let us see what is reference band. I click reference band and drag it over here. And I click on OK. Oh, it is showing me maximum value. So maximum band is over here and minimum band is down here. So for maximum and minimum value, broader the band, serious is the situation. If all the students had done well, this band would have been narrow. So one student has got 12 marks. Because of that, one is 14, one is 17. My band is so broad. So broader the band of minimum and maximum. So what I'm seeing is I'm looking at the spread of the data. I'm looking at the spread of the data comparative, and I'm looking at the spread of the data horizontal also across the students. And the same thing I can do with grade, class 9 and 10. Instead of a student, I could have taken grade. For example, I go to data and I take grade over here. And from here, I add grade and I remove a student. Did you see? 9, 10 grade is over here now. Instead of sum, I take the average. Does not matter because, here average matters because there is only one class of 9th and one class of 10th. So I take the average over here. When I'm dealing with a group of data, average is one basic value. So here the scenario is quite different. My class 10 is doing very well, but my class 9th is not doing so much, not even halfway. You see 38 and 72. So I have shown you different aspect, grade wise, student wise, it could be test wise, it could be subject wise. So you can create your own data sets. You can create these visualizations in different parameters and you can show to the students. So this way you can figure with various visualizations how to see the data. I have used only the histogram, or I have used a bar chart or column chart. You can go with, and I have also showed you scatter chart. A scatter chart is always used to see the correlation between the data values. So that I had already shown you. In Show Me tab, you can go for other types of charts also if that suits you. You can go for these charts. So many charts are open. Bubble chart is there. I can change the value to this one. So this is not very conducive. Class 10th is there, class 9th is there, very small. I can go for this one or this tree map. So there are various types of visualizations for different kind of people. So this is a data table simply. A summary table is there. So this way I can create various visualizations and I can use them. So I have kept the examples small so that the purpose was to get familiar with the Tableau interface first of all. And then I showed you in limited time what all simple visualizations we can do with Tableau. This is the very basic which you should know before moving into the class. I'm so grateful to you all to give me time to share this interesting detail with you. Thank you, all of you.